Hey, good day. Welcome to JCSF online tutorial class. Today we'll be doing physics, and I remain your humble master, Uncle JS. Now, for those of you who have not been joining our classes, so we've done a lot, and you can still have access to our previous classes by following JCSF, by subscribing to JCSF YouTube channel. So on YouTube, so you subscribe, you can have access to our online classes, where you can have access to the to our past classes that you have already skipped. So in our previous class, we tried to look into work energy and power. So this takes much of our time, but we have finally done with work energy and power. Now, today we will be starting with scalars and vectors. So we'll be starting with scalars and vectors. So today we'll be talking and explaining what we need to understand about scalars and vectors. Now we'll be talking about the concept of scalar quantity, and talking about the concept of vector quantities. So from there, we can now look into the distinction between scalar and vector. So we look at the distinction between scalars and vector. And we now look at representing vector, then representing the magnitude of vector, and addition of vector. So we will look into how we can quickly round up this topic. So probably today, because we have a lot at hand to do because of our examination that is approached both WASSCE and JAM. Now let's start with the concept of scalar quantity. So, and we talk about scalar quantity. What is a scalar quantity? A scalar quantity is a quantity that has only magnitude. So that has only magnitude, but no direction. So a scalar quantity is a quantity that has only magnitude, but no direction. So when we talk about scalar, they only deals with magnitude, but there's no direction in them. So there's no direction, they only have magnitude. So, and if we are talking about those objects or substances that have only magnitude, but no direction. So some of them are, we can talk about the speed, the volume, length, so the mass of a body, so the area, etc. So the above mentioned are example of scalar quantity for those of you that is jotting note. So length, area, so speed, mass of a body, volume, so etc. Here are examples of scalar quantity. So of scalar quantity. Scalar quantity are the quantity that has only magnitude but no direction. Now, all these mentioned only has magnitude, but they have no magnitude but no direction. So you can say magnitude of an area, you can say magnitude of speed, and the magnitude of mass of a body, but you cannot say direction of a length. A length will be length. So you cannot say the direction of area. Area will be area. So you cannot say the direction of speed. Speed will be speed. And the direction of mass of a body. Mass of a body is always the mass of a body. So we have briefly talked about the scalar and the vector. Now let us talk about the scalar quantity. Let us briefly talk about the vector quantity. The vector quantity. When we talk about vector quantity is that quantity so which has both a magnitude and a direction. Vector quantity has both a magnitude and a direction, unlike the scalar that has only magnitude but no direction. The vector quantity has both magnitude and direction. So that is vector. When we talk about those quantities, so that have both magnitude and direction, what are the examples? So here we can talk about the acceleration, force, momentum. We can talk about displacement. So velocity, etc. So here are examples of vector quantities. So they have both magnitude and direction. You can see accelerate, you can see it can accelerate at a distance, following a direction of, so it has a magnitude and it also has a direction. It's about applying the force, the momentum, displacement, and velocity of the body. So they have both magnitude and direction. So the magnitude of a body is shown by the length, so and the direction, so by the arrow representing the position of the direction. So the magnitude is shown by the length, so and the direction by the arrow representing the position. So the arrow that represents the position of the body will determine so the length and the direction so of the what of the body. The resultant of a scalar quantity is simply added algebraically. The resultant of a scalar quantity, just like when you add 2 plus 2 straight, so you get the final answer. So that is the resultant of a scalar quantity. So to find the resultant of a vector quantity, so simple algebraic addition is not applicable. You just have to understand this. So to find the resultant of a scalar, so a simple algebraic addition can be done. Then we get it done. The body of this side and this side, then we add it together. Then we get the final answer. But to find the resultant of 2 or more vector quantity, so simple addition. So the addition is done by applying the parallelograms law of the polygons law of vectors. So we talk about it as we move on. Now, so what you just need to what you just need to understand so far is trying to really talk about the scalar and quantity. I would say that scalar has only magnitude but no direction, but vectors have both magnitude and direction. I will talk about the example of scalars and vectors quantity. Let's look in the distinction so between scalar and vector. Distinction between scalar and vector. So scalar, vector. Now, what about scalar? So scalar has magnitude but no direction. Scalar has magnitude but no direction. So while vector has both magnitude and direction. So they have both magnitude and direction. Magnitude. So this magnitude and direction. Now, still, so the scalar involves size of magnitude alone. It only involves size of magnitude alone. In as much, the reason why it will only involve size of magnitude alone, in as much it has only magnitude. So it doesn't concentrate on other side. It only concentrates on the size of the magnitude. So now, why under vector involves the size of magnitude and also what? The direction. So you have to know another difference. Now, the vector quantity are obtained by mere addition. Obtained by mere addition. It's just like adding the direction and the magnitude. So together. Now, why this one also is obtained by the application by
I'm doing lesson.
the application of algebraic simplification. So that what am I training? So in our case, the application of some algebraic simplification is simple addition. So why
Mary.
Are obtained by mere addition. Laws such as Pythagorean parallelogram and polygon. We can make use of that. Now, let's look into one again.
Please mute yourself. Your this thing is disturbing us.
I'm sorry, sir.
Scalar introduce some new things. Introduce something. Scalar introduce something. Why vector give clear. Why vector give clear explanation? Now, in short, what you need to understand about the difference between the scalar and the vector is what we just explained above. Now, scalar has magnitude but no direction. Vector has both magnitude and direction. So scalar involves the size of magnitude alone, while vector involves the size of magnitude and direction. So why scalar are obtained by application of some algebraic simplification, just simplification. Why vector are obtained by mere addition, or we can also make use of the laws such as Pythagoras, parallelograms, and polygons law. So that is about the differences, the distinction between the scalar and vector. Let us move further. Now, let us now explain well about the vectors and cited some examples so we can comprehend what we're trying to explain. Now, we've explained that a vector for the exact quantity which has both a magnitude and a direction. So a vector quantity is a quantity that is fully described by both magnitude and direction. So it is fully described by both magnitude and direction. So on the other hand, so a scalar quantity is a quantity that is fully described by its magnitude only. So while the vectors are fully described by the magnitude and direction. So the scalar quantity is fully described by its magnitude. So the emphasis of this unit is to understand some fundamentals, so about vector, and to apply the fundamentals in order to understand motion and forces that occur in the two dimensions. Just need to understand, try to explain. So the emphasis of the unit is for us to understand some fundamentals, some principles about vector. So, and to apply the principles in order to understand motion and forces that occur in two dimensions. Because if you don't understand the fundamental, so it will be very hard for you to do what? To add, it will be very hard for you to understand the motion and the forces that occur in the dimensions. But if you understand the fundamentals, so it will be very easy for you to apply the fundamentals in order to understand motion and forces that occur in the both dimensions. So, and we've talked about some examples of vector quantity. So, there's some examples are the acceleration, the force, the displacement, and velocity. So, each of these quantities demand that both a magnitude and a direction are listed. That is, when we talk about the displacement, the velocity, the force, the acceleration. So, each of these quantities demand that both a magnitude and a direction are listed. Now, for instance, when if you are to, let me just put the example here. So if you are to told that, okay, maybe a ball so is located so outside the building. So let us know that they said there somebody is showing that a ball is located outside a building. And the person now tell you that to find the ball, you have to displace yourself 50 meters. So I'm just trying to explain so you can understand. So let's say that you were told that a ball so is located outside the building, and they are telling you to find the ball, you have to displace yourself like 50 meters. So this statement may provide yourself enough information to pick your interest. Yes, there is not enough information included in the statement to find the ball. Because, okay, we said that, okay, if you move out of the building, you find the ball. The ball is located outside the building. So maybe 50 meters outside the building. But you don't know outside the building where the ball is located. Now, for the reason, the statement may provide yourself enough information to pick your interest. But yes, there is no information included in the statement to find the ball. Because it is not described so that you have to go maybe to the west or to the south or to the north or to the east of the building for you to find the ball. So the displacement required to find the ball has not been fully described. So until it is fully described, before you can know where the ball is located. And this has to be provided for you to understand the significance of of the vectors. So let's say on the other hand also, suppose they tell you that the ball is located outside the building. So let's say somebody will tell you that a ball is located outside the building, 50 meters outside the building. Display yourself 50 meters. So outside the building, you get the ball. Now, no direction, nothing. You were just informed that so 50 meters so outside, so the building, you get the ball. But you don't know exactly where the ball is located 50 meters outside the building, because it can be in the south, it can be in the west, north, or east. So, but let's just assume that. So you are told that the ball is located outside the building, and to find it, you have to display yourself either from the center of where you are standing, So 50 meters in a direction, maybe 30 degrees to the west or of north, or 30 degrees to the south of east. Now, if the instructor provide you with such kind of information, now it will be easy for you to know how to locate where the ball is outside the classroom. And that is the importance of vectors. Vector will let you know the distance, the direction, and the magnitude. Now, when you are given a well-explanatory, so that to find it, so you have to display yourself from the center of that place where you have been ordered. So 50 meters in the direction, that's 30 degrees to the west of north. So this kind of statement will provide a complete description of the displacement vector. So this one will provide you a clear definition, a clear details about of the displacement vector, which is what? Which is the ball. So it leads the explanation leads you with the magnitude and what? And direction. The magnitude which we have already that is 50 meters, and direction which is what? Like 30 degrees to the west of north. And also relate the reference or starting position, the center of where you are standing. So a vector quantity will never fully describe unless both magnitude and direction are listed. So a vector will never be fully described. So unless both magnitude and direction are fully described. For instance, according to what we have explained now, to buttress our point, let us say that, okay, this is where we were being given an instruction that a ball so is located so outside this place, 50 meters outside this place. So 50 meters outside this place, now you don't know if the question is not well explanatory, you don't know, maybe it is this side 50 meters, maybe it's this side 50 meters, maybe it's this side 50 meters, maybe this side 50 meters. And if it's not given, it has to be given. And when the direction is given, so it will be very easy for you. Now, we've given that, okay, the ball is located 50 meters outside the Now, with this information, we can get clear of specific direction. So the vector diagram depicts a vector by use of an